Okay, we're going to go ahead and start the question and answer session. I'll go ahead and ask our first question. Can the leftover brine be used in salt treatment of northern roads in the winter?
I can go ahead and grab that. So the leftover salt that's in the water, just to give you an idea of how much salt we're talking about in the 50 million gallons that we're producing, we have a railroad track that goes behind the property, and if a train were to travel at 3 miles per hour, 24 hours a day, 7 days a week, we would be able to fill up every single car with salt. So just to give you an idea of how much salt we're talking about, we're very limited on our coastal site. The Carlsbad plant is on about a 6-acre site, so we don't have the capability to process that salt on site, as well as the fact that we don't have the need for salt for our roads here in San Diego County, so we'd have to truck that salt elsewhere. So it wouldn't be economically feasible. So good question. I get that a lot.
Great, thank you, Jessica. Okay, we'll go on to our next question. Were there any major challenges or lessons learned in incorporating a desalination plant with a natural gas power plant?
Sure. One of the benefits of co-locating the Carlsbad plant with the Encina Power Station is that we're able to use their existing intake and outfall. We are able to use that to get our source water. Even after the power plant is decommissioned, we'll still be using that open intake and outfall. Another benefit is that the area is zoned commercial industrial, so we did not have to change any land use there on the coast, which is something here in San Diego County. It's hard to find an industrial site right on the coastline. A lot of folks ask what will happen when the power plant is decommissioned about our power source, but we actually do not get our power from the Encina Power Station. They are a peaker plant and do not run all the time, and so we actually get our power for the Carlsbad plant from SDG&E, who's the local power wholesaler in San Diego County. We do not get it directly from the power plant where we're located.
Okay, thanks. The next question is, do any of you have any thoughts on solar evaporation of seawater for desalination?
You know, it's an interesting concept. People are studying alternative energy and renewable energy for desalination. The problem with the solar evaporation is that the solar density is relatively small, so you need very large area for collectors to collect enough energy to do desalination. And so solar is not the only one. Actually, in Australia, the Perth desalination plant built a large wind farm to collect renewable energy to compensate for the energy cost of desalination. And we have other projects looking at geothermal energy to derive the desalination with membrane distillation and other processes. So it's possible. It has more and other life cycle costs associated with that.
Thank you. Are there any programs being developed or that are already developed to make it more economically feasible to recover seawater or brackish groundwater?
I'll take this one too. The interesting thing about reverse osmosis is that the cost of desalination, the kilowatt hours needed to treat 1 meter cube of water are very, very close now to the thermodynamic limit of separation of water. So we're doing almost everything possible to make the process very efficient. Additional efficiency will come from better membranes. Even the energy recovery devices that I talked about and Jessica talked about it, just as energy recovery device, they are more than 95% efficient. So they are very efficient in recovering or converting the pressure energy into pressure in the feed stream. So they are good. You know, I wish that we had more progress in processes like pressure retarded osmosis to recover the energy in the brine. This is chemical energy that's highly valuable. We need more time and more research to make them viable.
I'll chime in too. I think it's also pretty important to realize that just in general, if you're desalinating water, that water is going to be more expensive than water that's treated with conventional processes. So basically, when you see desalination, it's where water scarcity has reached kind of some sort of limit where, you know, the municipality or whoever has decided that, okay, well, we're in like almost a crisis. There's a, you know, this large incentive. We really need this water, and so then we will desalinate. At least that's what you see in Texas. I'm not sure about in San Diego.
Well, let's go on to the next question. How much water would you need to desalinate to substantially reduce the amount of fresh water currently being removed from the Colorado River?
I can take that one. So, like I mentioned, San Diego County imports about 85% of their water from other sources. 60% of that is from the Colorado River. Again, the Carlsbad plant's producing about 10% of San Diego's supply. We do have the capability here on site in the future. If we were to build a phase 2, we could potentially build an 80 million gallon per day plant, but that would be the largest we could do here in Carlsbad. There are other plants in San Diego that are being studied right now. The feasibility for a 100 million gallon per day plant on Camp Pendleton is being looked at right now by the San Diego County Water Authority. And Poseidon is also working on a plant at the same size as the Carlsbad plant, 50 million gallons per day in Huntington Beach, and that is in the late permitting stage, hoping to be operational here in the next few years. And so there are some other opportunities in San Diego County or Southern California for additional desalination sources, but to be completely independent from the Colorado River, it would take, you know, 5, 6, 7 desal plants to be able to be completely independent.
Great, thank you very much. All right, we've got time for just one more question. So, how do you mitigate continued use of a brackish well regarding how that might affect saltwater intrusion of nearby wells?
So, I can take this. So the answer to this question is really going to depend upon geology. So if you've got, let's say, so some aquifers are confined and completely brackish. And then other aquifers might have a freshwater region, and then they might have, in the same aquifer, a region that's more brackish. So I think basically when you are planning which well to use and how much to pump, that process would be different if you had a well that was completely brackish, or a well that was in an aquifer that was completely brackish, versus a well that was in an aquifer that had a brackish zone and a fresh zone, where you would have to be very careful in designing your pump rates and looking at the aquifer in that fresh and brackish aquifer versus the sole brackish aquifer. And I would say that this is definitely an area where regulation might need to catch up to the engineering.
Okay, thank you very much, and thank you to all three of you for those great answers. That's about all we have time for today. Thank you everyone for excellent questions, and thank you to our excellent speakers. If you have any questions that were not addressed today, you can email them to us at cipinfo@americangeosciences.org, and we'll make sure to send your questions along to the speakers. This concludes our webinar for today. Thank you for joining us, and we look forward to seeing you next time.